Looking at section P.9, linear inequalities and absolute value inequalities. We looked a little bit about our linear equations and absolute value equations. Moving into our inequalities, there are going to be some new notations and ways of representing these that you do not have prior knowledge on from Algebra 1 or Algebra 2. So we are going to look at using interval notation, finding intersections and unions of intervals, similar to what we've already looked at in terms of sets of numbers, intersection, what's in common versus union, bringing everything together. And then we're also going to look at solving some linear inequalities. In the next set of video, or the next video, we'll look at solving compound inequalities and then solving some absolute value inequalities. Excuse me. So solving an inequality is the process of finding the set of numbers that makes the inequality a true statement. These numbers are called the solutions of the inequality, and we say that they satisfy the inequality. The set of all solutions is called the solution set of the inequality. Just like when we solve an equation, we get an exact answer. We have one value for our answer. When we're solving an inequality, we're looking at a set of answers. Something is greater than or less than a set number. So interval notation, as I mentioned, this is going to be a little different. It says the open interval, and they use parentheses, a comma b, represents a set of real numbers between, but not including, a and b. What would look familiar would be this a is less than x, which is less than b. That's our regular means for looking at an inequality. But now they're going to represent that as we're starting at a and going to b, but we are not including a and b. This piece right here, where it has that x and then that bar, that is read as x such that whatever they state after it. A is less than x, which is less than b. What that would look like on a number line. If we went back to our basic concept of a is less than x is less than b, we would have had an a and a b, and we would have had open circles, and we would have said that x falls somewhere between a and b. That's your Algebra 1 portion of it. What happens with looking at that open interval or interval notation is they are going to use these parentheses. And they're going to put a parenthesis at A and a parenthesis at B, and they're going to shade in between. So an open circle is a parenthesis. The next part says that the closed interval, and this time they use brackets, represents the set of real numbers between and including A and B. So again, if we went back to the basic concept on our number line, we would have had our A and our B. We would have had solid circles at A and a solid circle at B, and then we would have shown that all those numbers were in between because we had the or equals to. Now they're saying is we're going to take and we're going to use these brackets to show that we are going from A, including A, up to B and including B. So that's the new notation we're looking at. If you had an infinite interval, meaning you're going to an infinity, you're going to positive infinity or you're going to negative infinity, it says that represents the set of real numbers that are greater than A. So we're going to start at A, open parenthesis, and we're going to go to infinity, parenthesis. Infinities are always going to use the parenthesis because infinity is not a set value. It goes on forever till we have no clue. So they're always going to keep that as a parenthesis. So for instance, if I had on a number line, I had my A value, we are starting at A, open parenthesis, I'll do that in a color, open parenthesis at A, and then we would show that we are going towards the infinity, towards positive infinity. If we had the infinite interval negative infinity up to B, and this one includes B, it has that bracket this time, that means that we are going to look at, starting at B, we have a bracket, let me use a different color, sorry. I use a bracket at B, but now we're going towards the negative infinity. So I'm going off to the left, to the negative. And again, they're always going to use these parentheses around the infinities because it's not a set value. It cannot actually equal infinity since that's not a number. So that's what that next little blurb states. Parentheses indicate endpoints that are not included in the interval. Square brackets indicate endpoints that are included in an interval. And parentheses are always used with the infinity or the negative infinity. So let's look at an example. Express the interval in set builder notation and graph. So set builder notation was where we open up with those little squiggly things, the brackets, and then we're going to have, the braces. We're going to have an x such that. Now this says that we are going from 1 to 3.5. So maybe it's easier to start by graphing it and then writing the inequality. Maybe it's easier to go from the inequality to the graph, whichever way your brain likes better. This bracket means that I am including 1 as an endpoint. So 1 is going to be less than or equal to, because it's a bracket, x, which is going to be less than or equal to, because again I have another bracket, 3.5. That's my set builder notation. And if I take it to the graph, at 1, I'm going to put a bracket, positive 1, I'm going to put a bracket. And at 3.5, I'm going to put another bracket. So 3.5 halfway between 3 and 4. So that means I'm going to have another bracket in here. And that's just showing that I have my values that are in between 1 and up to 3.5, and I'm including those. If we were to look at the next one, it says express the interval in set builder notation and graph. We are having a negative infinity, and we have an open parenthesis at -1. So I'm going to go to the graph first. Open parenthesis at -1, open parenthesis at -1, and it is going to the negative infinity. So my set builder notation is going to say x such that x is going to be less than, and it's not equal to because it's a bracket, or it's a parenthesis, so it's just x is less than, and we would have a -1. Finding intersections and unions of two intervals. So step 1 says to graph each interval on a number line. And then for step 2, it says part A, to find the intersection, take the portion of the number line that the two graphs have in common. Intersection is what's in common. To find the union, it says take the portion of the number line representing the total collection of numbers in the two graphs. So remember, we talked about this prior to this lesson. So if we were to look, for example, finding the intersection and union. Now, we have some more notation that we're going to look at. We have this upside down U. And the best way for me to explain how to make that connection is an intersection. We have an N, intersection versus a union. So this means that we are going to have an intersection between that 1, 3 inclusive and the 2, 6 that are not inclusive. So they want us to graph each of these two pieces. So we're going to put each of these two graphs, and then we're going to look for the numbers that are in both. So if I were to start with a 1 to 3, I have a bracket at 1, and I go up to include a bracket at 3. So I'm looking at my numbers between including 1 and 3. Now if I look at my graph of 2 and 6, I have an open parenthesis at 2, and I have an open parenthesis at 6, and I'm going in between those. So then if I am looking for the intersection, I'm kind of looking at what's in between, or what's in common. Well, I start at a 2, so if I kind of look, I have this 2 in common, and I have a 3 in common. That kind of looks like all that I have. So if I am looking to see what's included, the least amount that I have is a 2, but I have a parenthesis at 2, so I have to go with the lesser. It's going to be a parenthesis at 2. And the greatest that I go to is a 3. Well, 3 is included in the second one, and 3 is included in the first one. So I'm going to have a bracket at that 3. So that means I'm going from parenthesis 2 up until a positive 3, and I have a bracket at 3. And that is how I would show that intersection. So solving a linear inequality in one variable. It says a linear inequality in x can be written in one of the following forms, as long as a cannot be equal to 0. If a is equal to 0, then you just have a number compares to 0, and that doesn't help us do anything. So if ax plus b is less than 0, we have ax plus b is less than or equal to, ax plus b is greater than 0, ax plus b is greater than or equal to 0. In general, when we multiply or divide both sides of an inequality by a negative number, the direction of the inequality symbol is reversed. So anytime you're solving to get x all by itself and you divide, multiply, or divide by a negative number, negative meaning opposite, that means you need to take the opposite inequality sign. Again, Algebra 1 stuff in that case. So solving a linear inequality. So solve and graph the solution set on a number line. So we have a 2 minus 3x is less than or equal to 5. Solve to get x by itself. Excuse me. So I want x all by itself. That means I need to get rid of a positive 2. I do that by subtracting. Negative 3x is less than or equal to positive 3. Dividing by that negative 3, I'm ending up with x. Now, if I'm taking the opposite, 3 divided by -3 would give me a -1. I also have to take the opposite inequality sign. That's what they mean by reversing your sign when you multiply or divide by a negative. So the solution set is going to tell us that x such that x is greater than or equal to -1, the regular normal way of solving an inequality. This then says that the interval notation for this solution set is, well, if x is greater than or equal to -1, maybe you have to go to the number line before you can write out the interval notation. We are starting at and including -1, and we are going to the positive infinity. That means we have a bracket, because it's or equal to a -1, and we're going to the positive infinity, but infinity has to have a parenthesis because it is not a set value.